Hi everyone! Welcome! Today we are diving into a fundamental aspect of C programming, dynamic memory management. Specifically, we will explore the essential functions malloc and free. These powerful tools allow your programs to manage memory efficiently during runtime, making your applications more flexible and robust. Understanding them is crucial for any C programmer. Let's start by understanding what dynamic memory allocation is all about. Normally, when you declare variables, their size is fixed and their memory is automatically handled by the compiler. It is created when a function starts and destroyed when it ends. But what if you don't know how much memory you'll need until your program is already running? What if you need a flexible amount of storage? This is where dynamic memory allocation comes in. It lets your program request memory from the operating system as needed and release it when it's no longer required. First, let's talk about malloc. The name malloc stands for memory allocation. You use malloc to request a block of memory of a specific size, measured in bytes. For example, if you want to store 5 integers, you might call malloc size of int 5. This tells malloc to find enough space for 5 integers. Malloc then returns a pointer to the beginning of that newly allocated memory block. It is very important to remember that malloc returns a void pointer, which means it's a generic pointer. You must cast it to the specific type of data you intend to store. So, our example would look like int myArray equals int malloc size of int 5. After calling malloc, you should always check if it successfully allocated the memory. If memory cannot be allocated, malloc returns null. You should always check for null to prevent your program from crashing. If myArray is null, you know there was a problem. Once you have a valid pointer, you can use this memory block just like an array to store your data. Now, let's move on to free. The free function is the counterpart to malloc. It is used to deallocate or release the memory that malloc previously allocated. This step is absolutely critical. If you allocate memory with malloc but never release it with free, that memory remains reserved by your program even after you're done using it. This situation is known as a memory leak. Memory leaks can accumulate over time, consuming more and more of your system's resources. This can slow down your program, make it unstable, and eventually lead to crashes, especially in long-running applications. To use free, you simply pass it the pointer that malloc returned. For instance, free myArray would release the memory we allocated earlier. After you free the memory, it becomes available for other parts of your program or other programs to use. It's also a good practice to set the pointer to null immediately after freeing it. This prevents what's called a dangling pointer, which is a pointer that still points to a memory location that is no longer valid. Setting it to null helps avoid accidental access to freed memory. So, why are both malloc and free so important together? They form a pair that ensures responsible memory management. Malloc gives you the resource, and free returns it. Think of it like borrowing a book from a library. You check it out, malloc use it, and then you must return it, free so others can use it. If you don't return the book, it stays unavailable. Similarly, if you don't free memory, your program holds onto resources it no longer needs, leading to inefficiency and potential problems. Using malloc and free correctly is fundamental to writing robust, efficient, and stable C programs. It prevents common bugs, optimizes resource usage, and helps your applications run smoothly over time. Always remember the golden rule. For every malloc, there must be a corresponding free. That's a quick but comprehensive look at malloc and free in C. Mastering these functions is a key step in becoming a proficient C programmer. They are powerful tools for dynamic memory management, enabling you to write more flexible and efficient code. I hope this explanation was clear and helpful for you. Thank you so much for watching this video. If you found this information valuable, please give it a thumbs up, and don't forget to subscribe for more programming tutorials and tips.